So for the polynomials, any factoring, refer to the foldable. We've already talked about that whole part of it. So if you didn't get that, I am collecting that as a formative. Make sure you check the website and you get everything filled in for that part. A lot of this test is basically knowing how to answer the question that's being asked. So the first thing I want to talk about is the different forms of a polynomial. If it's asked to write it in factored form, that's going to mean that you should have it in the parentheses with all of the factors. Where if it's asked for standard form, it's multiplied out and you have anything like x to the fifth, then x to the fourth, then x to the third, and so forth all the way down to your constant. Based on what question is being asked will determine what your answer will look like. So if the question is asking for the factors, then you're going to have the binomials normally, which are going to be the factors of the polynomial. If it's asking for the zeros, the roots, or the solutions, all of these are the same thing. Your answer should be x equals what your zeros, roots, or solutions. So you have to solve them and solve for that variable to find out what it is. You should always, when you're looking for the zeros, the roots, or solutions, always be trying to factor first. You only go to the rational root theorem or the rational zero theorem as your last resort. And the question is going to tell you to list the possible rational zeros for those and then find all the zeros. It's going to give you that hint. That's when you need to do it. So I'm going to abbreviate some of the theorems here. The factor theorem basically says if you have a binomial, if it divides into the polynomial evenly and the remainder is 0, then it is a factor. The remainder theorem says to find P of R is going to equal the remainder when you use it in synthetic division. You don't change the sign for that though. I'm going to put that in parentheses. You're given the x value, don't change the sign. Complex conjugate theorem says if a complex number is a root or a zero, the conjugate is also a root. So I put here, if an imaginary number is a 0, then the conjugate is also a 0. The fundamental theorem of algebra says there are a total number of roots is going to be the same as the degree. The details on that is that's including the multiplicities and that's including the imaginaries. The list of possible rational zeros is just your list of P over Q's. It's all the possibilities of P over Q, including plus or minus in front of each of them. If you want to write here, the P is the factors of the constant, the Q is the factors of the leading coefficient. All right, so that's it pretty much for this one. No joke today. I'm all out. Nah, I'll get you next time. I'll send you something through Twitter or Remind.